Hi dear students, welcome to Gallant IAS. So today we are going to deal with the questions that had been asked in our CSAT test series. So we will be discussing all the questions that had been asked, and so for those students who didn't take the test, you can download the PDF in the description box given below. So just download the PDF and try to solve the question by yourself. And if you don't have that much time, then just focus on to this video, and here you can see the question, and just after seeing the question, just pause the video and try to solve the question, and then you watch the discussion. Okay, so let us start with the questions. So here, another thing I need to say is that I will be only discussing the questions based on quantitative aptitude and reasoning, and the remaining questions, that is the comprehension side, it will be dealt by Justin George sir. So yeah, now let us start with the quant and reasoning kind of question. So here, starting with question number 5. A, B, C, D, E, F, G are the natural numbers of which the value number A is 2 times that of B, and the value number C is 1.5 times that of B, and the value number D is 4.5 times that of B, and the value number E is 2 times that of C, and the value number F is 4 times that of C, and the value number G is half that of D. So here you can see certain relations with certain variables are given here, and with the help of that relations, you need to find which is the highest value and which is the lowest. So you need to arrange this A, B, C, D, E, F, G, H in an ascending order, in a descending order, and you need to select the exact options given below. Okay, so exact options. So here, how to solve this question? So there are many ways you can solve this question, but I think the easiest way is just assume the value of B. You just assume some value for B and just find all the remaining variables, A, B, C, D, E. So already you assume the value of B, then you just find the remaining variables, right? So I'm using that method here. Here I'm assuming the value of B as 100. So it will be the most easiest way, right? Assuming the value of B as 100, then the calculation will be a bit more easier. So if you are assuming the value of B as 100, then value of A will be what? A is 2 times that of B, right? A is 2 times that of B, which means what? B is 100, so A will be 200. So likewise, you just find the remaining value. Value of C is what? C is 1.5 times that of B. 1.5 means what? 3 by 2 times, right? So 3 by 2 times that of B. 3 by 2 times of 100. That will be what? It will be 150, right? It will be 150. And C is what? D is what? The value number D is 4.5 times that of B. That is, D is equal to what? 4.5 times that of B. 4.5 times that of 100. It will be 9 by 2 times that of 100. It will be what? 50. It will be 450, right? D value will be 450. And the value of E is 2 times that of E. The value of E is 2 times that of C. So E is 2 times that of C. C is what? C is 150. Then value of E is what? 2 times that of C. Then value of E will be what? 2 into 150. It is 300. Value of E is 300. Then value of F will be what? Then value number F is 4 times that of C. The value number F is 4 times that of C. That is 4 into 150. 4 into 150, it is what? 600. So, and finally G. Value of G is half times that of D. Value of G is half times that of D means what? That is half into D value is 450. Half into 450, it is 450, it is 225, right? 225. Now you got all the values, right? You got all the values here. A value is 200, B value is 100, C value is 150, D value is 450, E value is 300, F value is 600, G value it is 225. Just arrange the values in the descending order, you will get the answer. So which value is the greater value? So here 600 is the greater value, so F comes in the first position. Then after 600, which will be the greater value? So after 600, it will be 450. After F comes, it will be D. Right? So after 450, which will be the biggest value? After 450, it will be E, 300, right? And so F, D, E. So you can eliminate option A and C, and you can focus on to option B and D, right? So after D value is 450. After 450, which value will be the highest value? After 450, yeah. After 300, after 300, which value will be the higher value? After 300, it will be 225. It will be G, right? G will be the fourth position, right? After 225, which will be the highest value? It will be A. After G comes, it will be, after 225, which value will be higher value? It will be A, right? So option D will be the answer, and you can eliminate option B, right? So here after G comes, it is C, right? After G value is what? G value, it is 225 and C value is 150. But after G, there is another value A, which is in between G and C. So the fifth value, it will be 200, right? So that is A will be the fifth value. But in option B, it is C is the fifth value. So option D will be our answer. F, D, E, G, A, C, B. Yeah, it is actually a very simple question, right? It is actually a very simple question, right? So this is a simple, very simple question. Now our next question. Okay, now check on to the question number 6. So this is actually the next question. So which of the following statement is or are correct? So you can see 3 statements, and yeah, you need to check whether which of the following statements are correct. So if you are checking onto the questions from 2021 onwards, you can see that UPSC is asking the statement kind of questions in CSAT, right? So yeah, this is another kind of question. So the question is, 3 statements are given. So the first statement is, all the prime numbers except 2 and 3 can be written in the form of 6k plus 1. Okay, all the prime numbers except 2 and 3 can be written in the form of 6k plus 1 or 6k minus 1 for any natural number k. That means if you are assuming any prime numbers, that can be written in the form of either 6k plus 1 or 6k minus 1. For example, assume the number 23. 23 is a prime number, right? So how you can write 6k in the form of 6k plus 1 or 6k minus 1? You know that 6 into how many times it is 24? 6 into 4 times 24, and then minus 1, you are getting 23, right? That is 6 into 4 minus 1. That is, here the k value is 4, right? So you are getting 23, right? So you can write in the form of 6k minus 1, and just assume another prime number 13. Just assume another prime number 13 that can be written in the form of 6 into 2 plus 1, right? So 6 2 times 12, 12 plus 1, it is 13. So that means if you are assuming any prime number, you can write either in the form of 6k plus 1 or you can write in the form of 6k minus 1. So if you are assuming, for example, we assume the number 23, 23 can be written in the form of 6 into 4 minus 1. But if you are assuming 13, that can be written in the form of 6 into 2 plus 1, 6 into k plus 1. So all the prime numbers except 2 and 3 can be written either in the form of 6k plus 1 or 6k minus 1. Yeah, that's actually the correct statement. Statement 1 is correct. All natural numbers which can be written. So now let's look on to the statement 2. All natural numbers which can be written in the form of 6k plus 1 or 6k minus 1 will be a prime number. So check this statement. All natural numbers which can be written in the form of 6k plus 1 or 6k minus 1 will be a prime number. That means all the numbers which can be written in the form of 6k plus 1 or 6k minus 1 will be a prime number. That's actually the statement meaning, right? So I will explain it. For example, suppose just take the k value as 2. Okay, when you are assuming k value as 2, then 6 into 2 plus 1, yeah, here you are getting a prime number 13, right? Now, for example, so 6k plus 1 satisfies the condition. Now look here, 6 into 2 minus 1, what value you are getting? 6 1s are 6 2s are 12. 12 minus 1, it is 11. Again, you are getting a prime number. So yeah, you got 2 prime numbers, right? Now assume the value 3 for k. Now if you are assuming the value 3 for k, then 6 into 3 plus 1. 6 1s are 6 2s are 12. 6 3s are 18 plus 1, it is 19. And 6 into 3 minus 1. 6 into 3 minus 1, what value will you are getting? 6 3s are 18. 18 minus 1, 17. Again, you are getting a prime number. So yeah, maybe this statement 2 can be correct, right? Now let us assume some more values. So 6 into 5. 6 into 3 you already assumed, right? 6 into 3, it is 24. Sorry, 6 into 3. Sorry, 6 into 4, right? 6 into 4, 6 4s are 24. 24 minus 1, you are getting 23. Right? But 6 into 4, so here this is minus, right? Hold on 1 second. Okay, now 6 into 4 plus 1, what value you are getting? 6 4s are 24, 24 plus 1, 25, 25 is not a prime number. Okay, so here when you assumed the k value as 2, then you got 6k plus 1 and 6k minus 1. In that, when you assumed the k value as 2, you got two prime numbers, right? 13 and 11. When you assumed the k value as 3, then you got again two prime numbers, 19 and 17. Yeah. So you think like, yeah, that statement 2 is actually satisfying the condition, right? But when you assumed the value 3 for the k, when you assume the value 4 for the k, so look here, 6 4s are 24, 24 minus 1, 23, you got a prime number. But in case of 6 into 4 plus 1, in case of 6 into 4 plus 1, you got 25. 25 is not a prime number. So this statement here is saying that is actually wrong. Statement 2 is wrong. That means statement is saying that all the numbers that can be written in the form of 6k plus 1 or 6k minus 1 is a prime number. Okay, will be a prime number. They are definitely saying that that number will be a prime number, but it is not. We already proved that a non-prime number can be also written in the form of either 6k plus 1 or 6k minus 1. If you are looking on to any other k value, you will be getting the example for 6k plus 1 also. Right, so statement 2 is wrong. Now what about statement 3? If p is any prime number other than 2, then p square minus 1 will be divisible by 24. If p is any prime number other than 2, then p square other than 2 and 3, then p square minus 1 will be divisible by 24. Yeah, actually that statement is correct. Now let us check. So other than 2 and 3, assume the another prime number. Let it be 5, right? 5 is a prime number, right? So p square minus 1, right? P square is what? So p is 5. It is a prime number. 5 square, it is 25. 25 minus 1, it is 24. 24 is divisible by 24, right? 24 is divisible by 24, right? Now assume another prime number, 7. So when you assume p as 7, p square minus 1, what value you are getting? P square minus 1, 7 times 49. 49 minus 1, it is 48. You know that 24 2 times is 48. Again, this condition is satisfying. So for any prime number what you're giving, you can see that for the value p, that condition is satisfying. So statement 3 is satisfying all the conditions for p, all the values for p except 2 and 3. So the third statement is correct. So the correct statements are 1 and 3. But in our question is what? So here the question, which of the following statements are incorrect? So the question is, which of the following statements are incorrect? That means we need to find out which statement is incorrect, and we know that statement 2 is incorrect. So our answer is what? Only 2. Option C is the correct answer. Only 2 is the incorrect, and statement 1 and statement 3 is correct. Okay.